Hello, and this is a recap to a technical blog post on how to authorize access to protected resources using the OAuth 2.0 protocol. I want to begin by highlighting kind of the alternatives that were typically used before OAuth 2.0 became the industry standard in authorization to do things like use resources via an application, maybe programmatically call an API without the use of a username and password. So as our example, we're going to go over here and just do a reminder on how to query a Centrify platform using the Red Rock API, which on the developer.centrify.com website, there's a lot of great information. In order to make an API call, you obviously have to be authenticated. And so typically the most basic form of authentication to go ahead and execute a Red Rock query API call would be supplying administrator or service user simple username and password. However, this could be problematic because you obviously have to store that username and password somewhere, and you don't typically want to have that just sitting in clear text somewhere in a properties or configuration file. So our alternatives before we introduce OAuth 2.0 is certain ideas like issuing a user certificate. The Centrify API, albeit a little bit outdated, does support issuing user certificates in which I can call a particular Centrify environment using core/issue user cert, right? And I can go ahead and request a certificate. Now this is a X2509 version 2 encrypted certificate that I can then use for subsequent API calls. Now it's a little bit kind of like the chicken before the egg model, where in order to obtain the certificate, I actually have to supply a username and password via API. So again, we're kind of stuck in the same place. But once I have the certificate, I can use a different API call to do what's called negotiate cert security /SSO. And so what that's going to do is it's going to take my user certificate, right? And it's going to translate that certificate into a cookie or a ASPX auth token, which you can see here. Now, what's interesting about that is I was able to generate the cert by supplying my username and password, which then in fact gave me an auth token or a cookie, which then that cookie allowed me to generate the cert, and then I translated the cert into an auth cookie. So as you can see, it gets a little bit cumbersome, and you figure to yourself, there's got to be a better way to authorize access to protected resources. So that's where our OAuth 2.0 functionality comes into play, where we can create bearer tokens, but instead of going through the process of supplying a username and password and getting the certificate and all that stuff to eventually come up with a bearer token that can be used to call APIs, we can go ahead and leverage our application that we set up as a OAuth 2 client. So let's quickly look into the application details. You see I've created the application with a unique application ID. Under general usage, I've selected confidential, must be OAuth client. The thing to remember here is that the OAuth 2 protocol can be used in a lot of different ways. So this is one example and one flow. Keep in mind that there are a lot of different ways you can implement OAuth 2. For this example, we are using the confidential flow. And so in order to do that, we have to have a OAuth confidential client, which in our example is essentially a service user. We provide this handy link here, are provided with this handy link here to create a OAuth confidential client user as part of our user directory if we haven't already. I'm going to say no because I already have this user. You see the issuer here. This is essentially the issuer of the tokens, right? So this is my OAuth2 server that's going to be, or my issuer that's going to be acting as my OAuth2 server, which can actually generate and provide tokens. Under the token section, you can see we defined our token type as a JSON web token encrypted in 256 bit encryption. Under auth methods, again, there's a lot of different flows here. We've selected our client credential flow, which corresponds with our general usage specification here under tokens. Or excuse me, under the general usage, our confidential selection corresponds with this auth method for client credentials here. We've specified a token lifetime of 5 hours, so when the authorization server, in this case our OAuth2 client, provides this token, it's how long it's valid for, right? You probably don't want to have this be indefinite, obviously for security reasons. Under scope, so this we can define scope definitions, and in our example we've defined a reporting scope. So we are allowing REST APIs to be utilized by a service account or maybe an application, right? And so we are defining a REST representational state transfer regular expression here. And so what this is saying essentially is that if you want to use the Redrock Query API interface, you have to have a token in order to do that. So we go under user access. You can see we've defined this OAuth2 client token access for these reporting APIs. We're going to restrict that to our service users. Now, if we go over to our service user role, we can do a quick check on our members. So our members here are service users, and part of the role as well, we've got read-only system administration. This is what actually allows us the rights or the privileges in order to access the system level data via API. And you'll see under assigned applications that we've got our OAuth2 client application that we set up. This is important, that's included here. Let's go back to our members. The member we're going to be using in this example is going to be our OAuth client ID at cloud.net. We can find that user by going over to all service users and selecting the user. You can see here that the OAuth client ID user is selected as a service user. Password never expires, and the probably the most important part is OAuth confidential client is selected as well. Now, when this user was created, it asked me to input basically a username and password for the user. In the OAuth2 spec world, it's client ID and secret. So you can go ahead and generate that client ID and secret, where the client ID essentially is going to be OAuth client ID at cloud.net. So if we go back to our application, we can, once we've successfully configured everything, we can create a bearer token for this user to be used to have an application access these Bedrock APIs. So again, our client ID is our service user, OAuth client ID at cloud.net, and our client secret was established when we created the service user. I can now select Get Token, and you can see our bearer token is generated for this service user. Now to copy to my clipboard, I can go ahead and click Copy here, and I'm going to close this. And I'm going to head over back to Postman, and we're going to see if we can make some REST API calls using this bearer token. Now, in this example, we're doing an HTTPS post, and here is our tenant, right? You can see the issuer, right? That's my centrified tenant address, and the APIs that we're invoking as part of the example is Bedrock/query. Now, in the body of our post, we've got a script, which is simply going to be doing a query on the application tables in relation to the centrified tenant. And so we're just doing a basic query for the last 30 days to get information about application access. So in our headers, we've got X centrified native client set to true. We've got a content type as application JSON. And as far as authentication, we don't have anything, authentication authorization, we don't have anything specified in the headers. We don't have anything specified here, right? But just to make sure that we don't have anything that's actually going to sign us in, I want to go ahead and get rid of all the cookies that have been generated by previous sessions. You can see they keep sneaking up, so I'm going to keep deleting these until they're all gone. So I've got no cookies available, right, to run this. I've got no prior authorization to run this API call against the tenant. Check our cookies again. Nothing in the headers, nothing in the body is doing any kind of authentication. Nothing in the address itself. So what should happen is I should hit send for this HTTP post, and I should get exactly what I just got, which is you do not have access to this content. So I'm not authorized, right? Because I never supplied a username and password. I never supplied a token. But our bearer token that was established as part of our OAuth2 client configuration will actually grant us access to this query interface. So what we have to do is we've got our token, which is still copied from our clipboard, right? After we selected create bearer token. And I can actually paste that here in Postman, and what I'm going to do for the value, I'm going to select, or type rather, the word bearer and then a space. So you want bearer, then a space, and then our bearer token that we generated in our centrified tenant. The name here is going to be authorization. Now Postman is going to take these headers and it's going to package them up as part of the HTTP request. Now I'm still within my window, right, because our valid token expiration time was 5 hours, so it's only been a few minutes. So I can go ahead and click send, and you see that I am able to authorize using the bearer token and successfully get back our our query response, right? Our result set. So if I do a Command Alt C, I can open up the console here, and I can click send again. Didn't work. Click send again, and you see here in the console, it's a little more just a different view of essentially the same thing. But here's the request header with our bearer token that we got from our OAuth2 client. So that concludes our session on how to authorize access to protected resources via OAuth 2.0. We were successfully able to invoke our API endpoint to run queries against our Centrify tenant without the need to supply our application with username and password in clear text, which is always good for security. We generated our bearer token through the user interface in Centrify after configuring our OAuth 2 client application and our service user, which served as our confidential client through client ID and secret. As I mentioned, there's a lot of different ways to incorporate the OAuth 2 protocol, and so there's going to be some follow-up videos on this for sure. Probably the next one will be how to obtain the bearer token programmatically, which essentially is invoking a URL token endpoint by supplying the grant type as client credentials. So instead of supplying them in the user interface in Centrify, you can actually include them in an HTTP header request to a token endpoint, get the bearer token, and then be able to use that bearer token. However, nonetheless, we are staying secure by not having to use a clear text username and password in a configuration file. Hope you found this video useful. Thank you.